what we're going to talk about here is combined variation. Now, this is the actually last type of variation that we're going to talk about. Now, combined variation is the relationship that contains both direct and inverse variation. Okay? All right, and now quantities that vary directly, they will appear in the numerator. And quantities that vary inversely, they appear in the bottom of the fraction, which is the denominator. Okay? Let's actually see what this is going to look like here. Let's start off with an application. Let's say that the volume of a gas varies inversely as the pressure. So the volume of a gas, let me write this question here. Okay, this here says the volume of a gas varies inversely as the pressure P and directly as the pressure T. Okay, a certain gas has a volume of 10 liters, a temperature of 300 kelvins, and a pressure of 1.5 atmospheres. If the gas is compressed to a volume of 7.5 liters and is heated to 350 degrees Kelvin scale on the Kelvin scale, what will the new pressure be? Well, this says this is what we call a combined variation because it contains the relationship between inverse and direct variation. Okay, so it says the gas. Now remember, I told you earlier, it says quantities that are directly, they appear in the numerator. So it says the volume of a gas varies inversely. So the volume, it varies inversely. That'll be K over as the pressure P. So it varies inversely as P. So that means it'll be P in the denominator. Now remember, because it says that quantities that vary directly are in the numerator, and quantities that vary inversely are in the denominator. So P varies inversely, so it's in the denominator. It says as a temperature, it says, and P varies. The pressure P and directly as the temperature. Okay, so it says the temperature is varying directly as a temperature. So that all quantities that vary directly appear in the numerator. So it'd be T in the numerator. Perfect. So we're looking at V is equal to the constant variation times the temperature divided by P. Perfect. This is the formula that we're going to use. Now let's go ahead and use the information given to find what K is equal to. Well, this will be V is equal to, what is V? What is our value of V? Well, in this case, to find what K is, V would be equal to 10 liters. So 10 liters is equal to K times a temperature of 300 degrees, 300 kelvins, divided by a pressure of 1.5 atmospheres. So 1.5 with P. Okay, so if we simplify this, so if we if we divide both sides by 1.5 in order to start the process of solving for K, we will get these to cancel. Then we're left with 1.5 times 10, and we end up getting, 1.5 times 10. Okay, so we'll have 1.5 times 10, which we already know that's going to be 15 because we just moved the decimal place over one time. So that's 15, which is equal to 300K. Now we can divide both sides by 300 in order to isolate K. And we'll get 15 divided by 300, and we'll get K is equal to 0.05 because these 300s cancel. K is equal to 0.05. Now that I have my K value, I can actually go ahead and use this to answer my question. So let's write the formula. The formula is V is equal to 0.05 times the temperature divided by the pressure. Okay? It says if a gas is compressed to a volume of 7.5, okay, so that'd be 7.5 liters, and this is compressed to a volume of 7.5, which is equal to 0.05 times the temperature. The temperature is 350 kelvins divided by the pressure. Well, what is the pressure? So we're solving for P. Well, since we know K, let's go ahead and clear this out so we'll have some space to solve for P. Well, all we're going to do here, let me bring this equation up here just so we'll have some space. So 7.5 is equal to 0.05 times 350 kelvins divided by P. Well, if we simplify this numerator here, we'd get what? Well, 0.05 times 350. We're left with what? Well, we're left with 17.5. So we have 7.5 is equal to 17.5 over P. And if I multiply both sides by P to get rid of that fraction there, I'd get 7.5 times P is equal to 17.5. And 17.5, I'm going to divide by both sides by 7.5. Let me see, I'm going to divide both sides by 7.5. And I'm left with the pressure is equal to 2.3 repeating, because that's what 17.5 divided by 7.5 is, 2.3 repeating, or as a fraction, I'm left with 7/3, okay? So that means that the new pressure will be 2.3 atmospheres, 2.3 atmospheres. I'm using the abbreviation of atmospheres. Where are we at? Abbreviation of atmospheres. Okay, right here is ATM. Okay, so I'm looking at a pressure of 2.3, or like I said, 7/3 or 2 1/3, whichever you prefer.